Aricia by the night sky, the night sky. Aricia by the night sky. First, the states of matter at a molecular level. All particles have energy, but the temperature varies depending on the sample of the matter is in. This, in turn, determines if the sample is solid, liquid, or in a gaseous state. Molecules in the solid phase have the least amount of energy, while gas particles have the greatest amount of energy. Here, you can see how the solid particles are tightly packed together, so they don't have that much space to move, such as the gas particles, which are more free to move. So, what is thermal energy exactly? Tiny particles in solids, liquids, and gases are always in motion. It is the motion of the particles that creates a form of energy called thermal energy. That energy is always present in matter. So, how exactly does this energy get transferred? There are three ways: convection, radiation, and conduction. Conduction is the transfer of heat energy by direct contact. Convection is the movement of heat by actual motion of matter. Radiation is the transfer of energy with the help of electromagnetic waves. In this image, you can see the three forms of thermal energy. Conduction, because the person is touching the pan and getting burnt. Convection, when the water is heating up and going up and down. And radiation, where the hot plate is heating up the pan with water. How heat conduction differs in conductors and insulators. Conductors are materials that allow electrons to flow freely from particle to particle. Insulators are materials that impede the free flow of electrons from atom to atom and molecule to molecule. Here are a few good conductors and insulators. Good conductors can be silver, copper, aluminum, and brass. Poor conductors or insulators can be vacuum, air, body fat, glass, or water. The reactants and products in a chemical reaction. All chemical reactions involve both reactants and products. Reactants are substances that start a chemical reaction, and products are substances that are produced in a chemical reaction. Chemical reaction by energy type. Most chemical reactions can be classified into one or more of 5 basic types: acid-base reactions, exchange reactions, condensation reactions, and oxidation-reduction reactions. Factors that affect reaction rates. Reaction rates can be affected by several factors, such as concentration, temperature, surface area, and presence of a catalyst. So let me explain this a bit more. I'm going to use uranium as my example because it's one of the things used in an energy power plant. This is a uranium atom, which is what they use in the power plants. When the nucleus of a uranium atom captures a moving neutron, it splits in two and releases some energy in the form of heat. Also, 2 or 3 additional neutrons are thrown off. If enough of these expelled neutrons cause the nuclei of other uranium atoms to split, these releases further neutrons and it can cause a chain reaction. Essentially, this is what a chain reaction of uranium atoms would look like. This chain reaction happens over and over again. Large amounts of heat is produced from a relatively small amount of uranium. Here you can see a worker holding up a uranium pellet, which is really small and makes large amounts of energy. Uranium is an abundant metal and full of energy. One uranium fuel pellet creates as much energy as 1 ton of coal, 149 gallons of oil, or 17,000 cubic feet of natural gas. You can see some of the uranium pellets that are used in those plants. Here you can see what a factory would look like, and the control rods in the reactor is where the pellets are used to make electricity. Then where the steam of the burning goes to the turbine, which generates electricity. And they also condense the water that they use to heat up the plant, and that also converts into water vapor and energy.